Hi everyone, today we will discuss a medium hard level binary tree problem. LeetCode algorithm problem 102 binary tree level order traversal. First, let's see the description of this problem. Given the root of a binary tree, return a level order traversal of its nodes values. For level order traversal, we will traverse the nodes from left to right level by level. For example, for this example, we will have 3, 9, 20, and 15, 7 as level order traversal, and our output actually is a list of lists. Here, we will discuss, as we discussed before, there are two main algorithms to solve tree problems. The first one is recursion, and the second one is to use breadth first search to traverse the tree and store the nodes in a queue structure. Today we will use the second one. Firstly, we use a Python list to store our results, and we need to consider if the root is none, and we will return the empty list as the result. This is a special case, and then we will think about the common case. Firstly, we use a variable level to indicate the level. So for this one, we will have level 0, and for these two nodes, we will have level 1, and for these two, we will have level 2. And we use a Python double-ended queue to store the queue structure. For Python double-ended queue, we will use append to append nodes from the right side of the queue, and we will use pop left function to pop nodes from the left side of the queue. That's why it's double-ended. To initialize the queue, we will store our root node in the queue. We use a while loop to traverse the tree. From the very beginning of a new iteration in the while loop, the queue only stores the nodes in current level, and we will store the length of the queue, which is also the number of nodes in current level, and use this for the range for the for loop to traverse it. And firstly, we will append a new list, and in the new empty list, we will store the nodes in current level. And here we have a for loop, and the I is in range between 0 and the current level length, which is also the number of nodes in the current level. And we will pop the nodes from the left one by one, and store the value of the nodes in current level in the new list. And we will add the child nodes of the nodes in current level from the right side, because the child nodes will be out range of the for loop, so they will not be traversed in current level, and will be stored and traversed in next iteration. After this, we will add 1 to the level number, and then we will finish the traversal. Here we will use this example to illustrate the while loop. Firstly, we will have the root in the queue, and this is level 0. The current level length is the number of the this list, and so the current level length will be 1, and the queue now will be the root node 3, and here we will append a new list. Then we will pop the node from the left side of the queue, so we will pop 3 and store the value of the node 3 in the result, and we will append the child nodes of the root. So it will be the 9 and the 20. And because of the current level length is just 1, we will finish this for loop. And we can say the node 9 and node 20 is stored in the queue and will be traversed in the next iteration. And we add 1 to the level number. Then we go to the level 1. And in the level 1, we will read the length of the current queue. So the length of the current queue is 2, which means there are 2 nodes in the current level 1. And we have 9 and 20 in the current queue. And we have the results here as 3, and we append a new empty list to store the nodes in current level 1. And we will pop from the left side of the queue. The first line is 9, and we store the value of the node 9 here, 9, and we will append the child nodes of the node 9. There are no child nodes, so we finished the node 9. And then we will have I equals 1, so we will deal with node 20, and we pop the we pop the node 20, store 20 in the result, and we need to append the children nodes from the node 20, so which will be 15 and 7, because our current level length is just 2, so we finished the for loop. And this queue will be stored and these 2 nodes will be traversed in next level, which is level 2. So here we go to level 2, and then the result now is 3, 9, 20, and we append a new list here, and then the current queue is 5 and 7. We firstly pop node 5 out and store the node 15 here, and there are no child nodes of node 15, so we finish node 15. And then we need to pop the node 7 out, and we store 7 here, and there is no child nodes of node 7, so we finished. And then we will see the queue becomes empty, so we will end up the while loop. Yeah, so this is our results, which is a list of lists. Yeah, as we can see, if we use the queue structure and use breadth first search, the while loop is very straightforward, and actually it's easier to understand than the recursion algorithm. Yeah, we will end now for today. Thank you so much for your time. Bye bye.